everyone, welcome to the session. My name is Vibhati and in today's session we are going to discuss few more amazing questions for your tomorrow's exam. Alright, so let's start with session. This is your NEET 10, a game changer series, and this is day number 10 where we'll discuss few more questions. Good afternoon everyone, good afternoon bachcho. So this is the timetable. 12 to 1 we'll be having physics, 1:30 to 2:30 we have zoology, then 3 to 4 botany, and 4:30 to 5:30 we have chemistry. Good afternoon everyone. Hello bachcho. Alright, so let's start with question number 1. Two objects of masses 200 gram, which is 0.2 kilogram, and 500 gram, which is 0.5 kilogram, like this. They have velocities v1 vector as 10I cap and v2 vector as 3I cap plus 5j cap respectively. The velocity of center of mass in meter per second is, you have to find the velocity of center of mass in meter per second. Try this one everyone. We have to find the velocity of center of mass. So VCM vector is m1 v1 vector plus m2 v2 vector divided by m1 plus m2. Okay, so try this one. You have 4 options in front of you, m1, m2, v1, v2, everything is given. Chalo. Prasanna, Chinni, Arjun, God, we have got present in our session. Okay, chaliye, try this one, try this one. No Nipuna, it's not tough, it's conceptual, it is based on basic concept. So if your basics are clear, then it's easy for you. Alright, come on guys, m1 is 0.2, v1 is 10I, m2 is 0.5 and v2 is 3I plus 5j. Divided by m1 plus m2 is 0.2 plus 0.5 is 0.7. So remove this point, we have 20I plus 15I plus 25ij divided by 7. So it will be what? 5 plus 25 by 7j, which is option C. Option C is the correct answer. Well done guys. Good job everyone. Let's move on to the next one. How much water should be filled in a container 21 centimeter in height so that it appears to half filled when viewed from the top of the container? You have to find ki how much water we should put in the container up to what height so that when you look at this from the top it appears half filled over here, right? So try this one, try this one. Refractive index of water is 4/3. Chaliye, try this one everyone. Here the ratio will be h upon 21 minus h should be refractive index of water. So it will be 3h is equal to 21 into 4 minus 4h. So we have 7h and that is equal to 21 into 4. So h will be 3 into 4, that is 12 centimeter, which is option C. Option C is the correct answer. Well done beta, well done. Chaliye. Let's move on to the next one. Statement A, moment of inertia is the desired rotational analog of mass in linear motion. Statement B, moment of inertia about a given axis of rotation resists a change in its rotational motion. Yes, see in mass, in rotational motion, we relate inertia with mass. Inertia is directly proportional to mass. Inertia is inability of a body to change its state of motion, or it is the property by virtue of which it resists the change in its motion, right? So in translational motion we have mass for that. In rotational motion we have moment of inertia for that, right? So statement A is true as well as statement B is true. Fine. So correct answer is option C. Both A and B are true. Next is this one. Which logic gate is represented by the following combination of logic gates over here? This represents which gate? OR, NAND, AND or NOR? Chaliye, try this one everyone. We have A, then we have NOT gate over here, then B, NOT gate, then this outputs of these two NOT gates are inputs of this NOR gate over here. Okay? So you have to find that this combination is behaving like which gate? OR, NAND, AND or NOR over here. A will pass through this NOT gate, it will become A bar. B will pass through this NOT gate, it will become B bar. Now A bar and B bar are the inputs to this NOR gate. So output of this NOR gate will be A bar plus B bar whole bar. So according to De Morgan's theorem, if you write A bar plus B bar whole bar, then it is equal to A into B, right? And A into B is nothing but the output of AND gate if A and B are the inputs. So correct answer is option C. This is behaving like what? AND gate over here. Chaliye. Next is this one. In Bohr's hydrogen atom model, the radius of stationary orbit is directly proportional to. So in Bohr's hydrogen atom model, the radius is 0.529 n square by z angstrom, right? This is how we find radius. So you can see that radius of nth orbit is directly proportional to n square. It is directly proportional to n square. Well done beta, well done everyone. Hello everyone. So it is option D. Next is this one. According to Einstein's photoelectric equation, the graph between kinetic energy of photoelectrons ejected and the frequency of incident radiation is. Try this one. This is again from modern physics. You have to draw the graph between kinetic energy and frequency. So this is the Einstein's equation in terms of kinetic energy and frequency and threshold frequency. So which graph represents this equation? 1, 2, 3 and 4. Okay, we have option 3 over here. See, it is a straight line. Y is equal to mx plus c. So on y-axis, if you draw kinetic energy, on x-axis we have frequency. So slope is equal to Planck's constant, which is positive. So slope will be positive, right? And y-intercept is negative. So slope is positive and y-intercept will be negative. So basically this is the graph and it is given in option 4 over here. So option 4 is the correct answer, right? So that is how you can identify. Alright, chaliye. Yes beta, if you know the basic concepts, this session will help you. What is the de Broglie wavelength of the alpha particle accelerated through potential difference V in angstrom? Again, this is something you should know. This is something you should remember as the direct formula. What is the de Broglie wavelength of the alpha particle if you are accelerating that alpha particle with the help of potential difference V over here? Chaliye, out of this 4, which of the following option is the correct formula? Which of the following option is the correct formula over here? Try this one everyone. Option 4. Option 3, option B, option A. De Broglie wavelength of alpha particle is 0.101 divided by under root of V angstrom. This is what we have as the direct formula, which is option C. Option C. This is for electron. This is for electron. ठीक है? Next is this one. The depletion layer in silicon diode is 1 micrometer wide and the knee potential is 0.6 volt over here. Then the electric field in the depletion layer is, what is the electric field value, right? So E is delta V upon D. Try this one, try this one. This is what we have, the relation between electric field and potential in terms of magnitude. E is delta V upon D. What is the value of electric field in this depletion region? Delta V is given, D is given, it is 10 to the power minus 6 meter over here. Do the calculation and let me know what is the correct answer, bachcho. Option C, alright, well done, well done. So here delta V is 0.6 and D is 10 to the power minus 6. So it is 0.6 into 10 to the power 6, which is 6 into 10 to the power 5 volt per meter, which is option D. So option D is the correct answer. Well done guys, well done. Chaliye. Now next is this one. If E vector and B vector represent electric and magnetic field vectors of the electromagnetic wave, the direction of propagation of electric wave is along. So velocity will be in which direction? In the direction of E vector, in the direction of B vector, in the direction of B cross E, or in the direction of E cross B. Again, this is conceptual question from electromagnetic waves. Every year you get one question based on this EM waves and you will be getting questions like this only, information based question, bachcho. Right, so velocity vector of EM wave is along E vector cross B vector. Right, so correct answer is option D. It is along E cross B. Fine. Chaliye, well done guys. Well done. Now let's try this one. In the given circuit, the voltmeter records 5 volt. The potential difference across these 2 points is 5 volts over here. What is the resistance of the voltmeter in ohm? This is 50 ohm, 100 ohm, this is 10 volt. So what should be the resistance of this voltmeter? Try this one. This is from current electricity, option D, option A, all right. Option C, I'm getting different options over here. See, it is quite logical. You don't have to solve this one. If you just go through the basic concept, this is total 10 volts, right? Out of 10 volt, 5 volt is dropping over here, hai na? And remaining 5 volt will drop across this resistance. Fine? Remaining 5 volt will drop across this resistance. So basically across this combination and across this resistance, the potential drop is same. In series combination, if the potential drop is same, that means what? That means the resistances are equal. That means the combination of these two should be 50 ohms. The equivalent value of this two will be 50 ohms and these two are in parallel, right? So resistance of voltmeter is, let's say, R. So we have 1 upon R plus 1 upon 100 should be 1 upon R equivalent, which is 1 upon 50. So 1 upon R is 1 upon 50 minus 1 upon 100, which is 1 upon 50. So from this one you will get 1 upon R is 1 upon 50. So R will be 50 ohms like this. Fine. So just try to observe the diagram. When it comes to current electricity, try to observe the diagram. You will be able to understand few things just by observing the diagram properly. Okay? Let's move on to this one. Statement A. Electrical potential may exist at a point where the electrical field is 0. Statement B. Electric field may exist at a point where the electrical potential is 0. Statement C. The electrical potential inside a charged conducting sphere is constant. Out of these three statements, which of these statements are correct. A and B are true, B and C, AC and AB and C are true. क्या होना चाहिए? Everyone. Which of the following option should be correct? Option B, option B. Alright. Electric potential may exist at a point where electric field is zero. So if you look at the hollow sphere, this is just an example. Hollow sphere mein, inside this sphere, electric field is zero, right? But electric potential is equal to constant, and that is equal to kq upon r, where q is nothing but the charge on the sphere and r is the radius of the sphere. So in this region, electric field is zero, but electric potential is not zero. So electric potential may exist at a point where the electric field is zero. This is true. You can see this thing. Alright, inside a charged conducting sphere over here, if you look at this one, so whatever charge you give to this conductor, that will come out on the surface. So if there is no charge inside, electric field will be zero and electric potential will be constant, right? Because over here, E is equal to minus dV upon dr. So if electric field is zero, potential will be constant. So statement C is also true. So all the statements over here are true. So correct answer is option D. A, B and C all are true. Chaliye, let's move on to the next one. The effective capacitance between A and B in the given circuit is, we have to find the effective value of capacitance between A and B over here. So this is the circuit. Try this one everyone. Find C equivalent between A and B. Find C equivalent between A and B over here. 3, 3, 3, 2, 3, 3, 2, 3, 3. Like this. 3 microfarad, 3, 3, 2, 3, 3, 2, 3, 3. क्या होगा? This 3, 3, 3 are in series, right? So their equivalent will be 1 upon C equivalent is 1 upon 3 plus 1 upon 3 plus 1 upon 3. So it is 3 upon 3, which is 1. So 1 upon C equivalent of this 3 is 1. So C equivalent will be 1. So basically this entire combination over here is equal to 1 microfarad. Now this 1 microfarad is in parallel with this 2 microfarad. This 1 is in parallel with this 2. So this 2 plus 1 will be the combination, that is again 3 microfarad. So this combination over here is 3 microfarad. Now again 3, 3 and 3 in series. So their combination will be 1 over here. This 3, this entire value is 3 and this 3. So these are in series. So their combination will be 1 over here, right? So this entire thing is equal to 1. Now this 1 is in parallel with 2. So 2 and 1 in parallel is 2 plus 1, 3. So this entire thing is equal to 3 microfarad. So ultimately what do we have between A and B? We have 3 3 and 3. 3, 3 and 3 between A and B in series like this. So series combination of 3, 3 and 3 is equal to 1. This is what we did over here. So final answer will be 1 microfarad. Option A is the correct answer. Well done guys. Chaliye. Try this one. Figure shows electric field lines in which an electric dipole is placed as shown in the figure. Which of the following statements is correct? The dipole is placed like this. This is non-uniform electric field. Statement A or option A, the dipole will not experience any force. Option B, the dipole will experience a force towards right. Option C, the dipole will experience a force towards the left. Option D, the dipole will experience a force upwards. Option C, well done, well done. So electric field, here in this region, the field lines are slightly apart. So this is the weaker electric field region. Here the electric field lines are closer. So this is the stronger electric field region over here. Now if you look at this, minus Q and this is plus Q. So at the location of plus Q, electric field is weak. So let's say it is E2. And at the location of minus Q, electric field is slightly more than E2. So E1 is more than E2 over here. Now this electric field is towards right. So force on this plus Q will be in the direction of electric field, which is QE2. Force on this minus Q will be in the opposite direction of the electric field. So if electric field at minus Q location is towards right, force will be towards left like this, and it is QE2. Right, QE1. Okay. So you can see that this dipole is experiencing QE2 force towards right and QE1 towards left. But E1 is more than E2, so definitely QE1 force will be more than QE2 force. So net force will be towards left. Net force will be towards left, and the dipole will experience a force towards the left. So correct answer is option C. Well done beta, well done. Chaliye, let's move on to the next one. A spherical black body with radius 12 centimeter radiates 450 watt at 500 Kelvin. If the radius is half now and the temperature is doubled, what is the new power radiated in watt would be? This is one of the PYQ from heat transfer. So power radiated is sigma A T power 4. A is the surface area, which is 4 pi r square for spherical body into T power 4. This is what we have for power radiated. So you have to compare for this and this to get the correct answer. Try this one. This is one of the PYQ guys. Try this one. Radius is half now and temperature is doubled. ठीक है, चलो. क्या आएगा बच्चों? For this power is 4 pi sigma r square is r by 2 whole square into 2t power 4, which is 4 pi sigma r square divided by 4 into 2 square into 2 square t power 4. So it is cancel, 4 cancel. So power in this situation, in new situation, is 4 pi sigma r square 4 times t power 4. Okay? Now here, when the power is 450 watt, it should be 4 pi sigma r square into t power 4. So basically this value is equal to 450. So new power is 4 times. You can take this 4 outside, 4 times 4 pi sigma r square into t power 4, and this complete value is 450. So it is 4 times 450, which is 1800 watt. which is 1800 watt, which is option D. Well done guys, well done. Yeah, calculation is there. Okay, so yeah, don't put this 12 centimeter and 500 because see, ultimately you have to divide this thing or compare this thing. So see, what I'm doing is I'm just doing the calculation in terms of R and T only, because when you divide, R will cancel R, T will cancel T. So you don't have to put this values as it is. Okay? So that way you can avoid the calculation. बच्चे नहीं तो 12 centimeter will be 0.12 meter. It will be lengthy for you to calculate. Then this 500 to the power 4 will be lengthy for you to calculate. ठीक है? चलो. Next is this one. A gas mixture consists of 3 moles of oxygen and 5 moles of argon at temperature T. Considering only translational and rotational modes, the total internal energy of the system is. You don't have to consider vibrational degrees of freedom. You just have to consider translational and rotational degrees of freedom for the calculation of internal energy of the system. So internal energy of the system is F by 2 nRT. F is the degree of freedom. For diatomic gas, degree of freedom is 5. For monoatomic gas, degree of freedom is 3. Okay, excluding vibrational modes. Try this one, try this one. You have to give your answer in terms of RT. 1, all right, well done, well done. Okay, so we have for this one, for oxygen, it is 5 by 2 N RT, plus that of argon, it is 3 by 2 N RT. So this is 15 by 2 RT, this is 15 by 2 RT. With positive sign in between. So 15 by 2 RT plus 15 by 2 RT is 30 RT by 2, which is 15 RT. So total internal energy of the system is 15 RT. Okay, well done guys, well done. Alright, next is this one. A real gas behaves like an ideal gas if its pressure and temperature both are high. Pressure and temperature are both low. C is pressure is high, temperature is low. D is pressure is low and the temperature is high. When the real gas will behave like an ideal gas. How many of you guys are appearing for NEET 2024? How many of you guys do you have exam tomorrow? Option D, well done. Ravalika. Okay, you guys are appearing for NEET 2024. So, can you do today's question easily? Option C, Shyam Sundar. All right. If you can do this questions easily, you have Rajalakshmi. Yes. Then you don't have anything to worry about, because your paper will be like this only, beta. It will be very easy. Out of 50 questions, you will get 45 questions easy and remaining 5 will be moderate to difficult. And you have the choice to choose in section B, right? Section B, you can avoid difficult questions altogether. Option D, well done. Okay, so don't worry about tomorrow's exam. Just trust in your preparation. Take proper amount of rest, sleep, and then go for your exam. All right. So, a real gas behaves like an ideal gas if the pressure is low and temperature is high. So, correct answer is option D. Option D is correct, bachcho. Well done, well done. Next is this one. The ratio of angular velocity of rotation of minute hand of a clock with the angular velocity of rotation of the earth about its own axis is. Try this one. ट्राई करो ट्राई करो. Option B. Well done, well done. Angular velocity of rotation of minute hand and that of rotation, angular velocity of rotation of the earth about its own axis. So the minute hand covers one complete rotation in 1 hour, and earth, it rotates about its own axis in 24 hours. So these are the time periods of rotation of minute hand and earth, right? So how do we find angular velocity? It is 2 pi by time period. So for minute hand, it will be omega 1, which is 2 pi by 1, divided by that of earth is 2 pi by time period of earth, which is 24. 2 pi cancel, so it is 24 divided by 1. So ratio is 24:1, which is option C. Option C is the correct answer, बच्चों. ठीक है? All right. Try this one. The torque applied to a ring revolving about its own axis so as to change its angular momentum by 2 joule second in 5 seconds is. So torque is rate of change of angular momentum. The change in angular momentum is given, time is given. Find the torque. Come on, yes. Well done, beta, well done. Yes, it is option C in the previous question. 24. Madhukar. Option D, all right. You will be getting questions like this only in tomorrow's session. If you have any doubt, just go through the previous 10 days of this particular series and try to solve few questions here and there. It will boost your confidence. Option D, option 1, option D, all right. Chaliye. So we have delta L as 2, delta T as 5, so it is 2 by 5, which is 0.4 Newton into meter, which is option D. All right, chaliye. Next is, when a compact disc is illuminated by a source of white light, colored lanes are observed. This is due to dispersion, diffraction, interference, refraction. Again, this is conceptual problem based on your NCERT. क्या होगा? This colored lanes are observed due to which phenomena? Dispersion, diffraction, interference and refraction. 2. Well done, well done. Vinutna, well done. Well done, Shyam Sundar. Well done, Madhukar. Well done, Ravalika. Well done, Ashley. Yes, it is due to diffraction over here. So correct answer is option B. All right. Next is this one. In an astronomical telescope, the focal lengths of the two lenses are 180 centimeter. The focal length of the objective is 180 centimeter and eye length is 6 centimeter respectively. The normal adjustment, the magnifying power will be. Normal adjustment, that means the final image is also at the infinity, right? So you have to find m infinity, the magnifying power when the final image is also at the infinity, m infinity, which is FO upon FE. Option B, option 3, okay. Try this one, bachcho. FO upon FE is the magnifying power for the normal adjustment over here. Option C, well done, well done. FO is given, FE is given. Well done, everyone. Well done. Yeah, it will be 180 divided by 6, which is 30. So this is the magnifying power, which is option C over here. Chaliye, well done. So that is it for today's session, everyone. All the best for your upcoming NEET exam. But if you are planning to take a drop, or if you are not appearing for 2024, we have Vedya 2025 batch for you. And if you want to be part of this ultimate NEET long-term course, you can fill the Google form which is given in the description box over here. And in this particular batch, we'll give you special focus on physics and chemistry. We'll focus on critical chapters more. We'll practice a lot of questions, like 20,000 plus questions. We have 30 weekend test and 15 grand test over here. Okay, so this is your ticket to your dream medical college. We are just a call away if you want to be a part of this particular batch over here. Fine. So if you like this session, like, comment, share and subscribe over here. And all the best, everyone. I'll see you hopefully in some other series or in some other sessions, but do well, prepare well. Now don't try to do anything new. Whatever you know, it is sufficient to crack the NEET exam. So just trust yourself and do well. Keep yourself hydrated, and I'll see you guys tomorrow in the NEET 2024 paper solution session. Take care, bachcho. Bye bye. All the best, everyone. Bye.